So I would like to do a live interface demo. If you go to SureChEMBL.org, this is the landing page. So you can query the database using different ways. For example, you can query the database using a keyword or a patent number, or alternatively, you can search the database by doing similarity search or substructure search. So you can sketch a compound or a substructure, or you can even, if you use this manual structure input, you can open this box and you can paste a name or a smile string, and this will be converted to the corresponding structure, and then you can do a chemistry search. And the very useful thing is that you can combine the keyword-based search with the structure search, and you can do both at the same time. And then there's also a number of filters that you can apply to your query, so that you can narrow down the results and go quicker to the results that you're interested in. So you can filter by the patent authority, for example, or by the date, or by the year of publication. And when it comes to chemistry search, you can even filter down by the document section where the compounds were extracted from. Finally, as you will see on the interface, on the landing page, there are lots of links that provide help. So we have a dedicated web page that has a number of articles that will help you use the functionalities of the interface. So please feel free to use these links and to find out more about what every searching capability provides. Right. So now I will try to do the live demo. So I will open up a browser. So this is SureChEMBL.org. This is the landing page. So the first thing that I can do is, for example, start with a very simple keyword-based search. I will use a trivial household item just to show you that that SureChEMBL system has access to all the patents available. So I'll just search for toothbrush, and I will click search. And these are the results. These are the patent documents where the word toothbrush occurs anywhere in the document. We have the patent ID, the publication date, the title of the patent, the signee information, and also the IPCR code. So for those that are not familiar with IPCR codes, this is a hierarchical classification system for patents, which is widely used. And it's very useful for us when we want to do when we want to query the SureChEMBL database, and I will show you an example later. So the document list of the hits is sorted in reverse chronological order. So it turns out that the last patent document that mentions toothbrush was published just yesterday, on the 10th of March, and this shows you how quick the system is to annotate the patent documents. So I'm going back to the landing page now. The other thing that you could do is you can start searching by a patent number or a list of patent numbers. As an example, I have here 2 patent numbers. These are formatted differently, as you can see. If you want to search, you will click this button called Patent Number Search, and you will paste the 2 patent numbers there. So they are formatted differently. One has a dash. They don't. Neither of them have the kind code, for example. But the system will try to resolve these to the corresponding documents. So if I click Search, there you go. The system resolves these to the corresponding SureChEMBL patent IDs, and these 2 are now available to look at. So if you click on this, on the first one, for example, you will be able to see the full text of this patent document. Going back, so I gave you a very simple example of a keyword-based search, but of course, SureChEMBL can do a much more sophisticated search. And for that, I will use the fielded search button, so here. So when you click this, there's a new window that opens. So you can search with a keyword, let's say diabetes. And in this case, you can specify the location, the section of the document where you want the word diabetes to occur. So let's say title or abstract. And then you can add more filters and more parameters based on the bibliographic data of the patent documents. So let's say, for example, that you want the assignee to be Novartis. And also, you can use the classification systems. So I'll use the IPCR system, and the IPCR system, the code for the organic heterocyclic compounds is C07D. So I'll use that to narrow down my results, my hits, to only the patents that include small molecules, small heterocyclic molecules, that I guess is the field that we're interested in. And I can also specify a publication date. So let's say that I want the patents that were published by Novartis in 2015. And I can click apply and search. And oops, sorry, let me go back. Oops, okay, let me repeat that. So diabetes, title or abstract, IPCR C07D, assignee Novartis. So I will do the same thing for 2014. Oops. There you go. There you go. So these are the results. So there were only 12 compounds, 12 patent documents that fulfill my criteria. What I can do here, I can go back, and if I want to add or remove a parameter from my search, I can fork my search. So I can click this button, and this will take me back to my original query where I can change some of the parameters. So maybe I want to change the year from 2014 to 2013. And I click search. And there you go. So there were 11 patents published by Novartis that have the C07D code, and they mention the word diabetes in the title or abstract. Let me fork this one more time. Use the 2014 here. There you go. So again, the results are listed, sorted in reverse chronological order. So let me see the full text document of the last patent published by Novartis in 2014. So this is the full text view of a patent document. You can browse through the three main sections, so the front page, the claims section, and the description section. And as you can see, all the chemical entities that were found by SureChEMBL are annotated in blue color. So you have some fragments here, like cyano and amino, and then you have the actual IUPAC names of the structures that are claimed in this patent document. So if you click on any of the highlighted entities, you get the corresponding structure as a pop-up. And if you scroll down, there are more IUPAC names of compounds that are claimed in the patent document, and then there will also be images of structures, and these are again converted by SureChEMBL to the corresponding compounds, which are available again. So if you click on a highlighted image, you will see the corresponding compound. Right, the other thing that you can do, you can of course export all the chemistry that is found within this document. So you can do that by clicking this button, Export Document Chemistry, and you're presented with a wizard. So if you want to remove the noise, so the reactants and the fragments, and if you want to keep only the truly claimed compounds, you can play with the parameters here. So for example, you can say, I want the compounds between 300 and 500 of molecular weight, and compounds with a log P of between -1 and 6, for example. Okay, and you click Export. So you see this pop-up here. So if you go to My Exports, you will see the export is waiting for you in either a CSV format or an XML format. So if you click Download CSV, you will get the CSV file with the chemistry exported by this patent document according to your criteria. So let me freeze that. There you go. So you have different columns. Every row is a compound. The compounds have names, the entities as they were found in the text. Every compound has a unique ChEMBL ID, SureChEMBL ID, smiles, and then you have a number of other properties, physicochemical properties like molecular weight and log P, for example. And you also have something which is very useful, which is the count of how many times this compound has occurred in the whole of the SureChEMBL patent corpus. So for example, these compounds have occurred only once in the corpus, so they're likely to be novel. But if you scroll down, there are more compounds that have that occur many times, thousands of times in the corpus. And if you see the names, these are compounds, names of drugs. So you get USAN and trade names of drugs that are mentioned in the patent document. These are converted to the structures, and they occur many times in the whole of the SureChEMBL corpus. If you scroll down further in this spreadsheet, you also get two compounds that didn't occur in the text, but they occur in an image or a more file attachment. And you see the provenance here, the type of the source. And again, you have SureChEMBL ID for these and all the properties calculated for these compounds as well. And I guess the last thing you can do is going back to the full text view. So you can also download the PDF, the original PDF of this patent document, which is here. Okay. So going back to the hits. The other thing you can do when you are in the document hit list, there are two other buttons here. One button with the two people. If you click this, you will retrieve all the patent family members for this particular document. So SureChEMBL also stores the patent family information for documents. So these are all the patents that have been filed in different countries, such as Australia, for example, or Korea, or China, and they're all members of the same patent family. And the other thing, if you want to quickly export the chemistry from this document without having to go through the full document view, you can click this button, again the same wizard, and you can start the export directly from this page. Right. Okay, so that was an example of a fielded search, so using different parameters, different criteria in order to find relevant documents. The other thing you could do the equivalent search using another way, which is this. So you can use a special Lucene query syntax. You can combine query fields such as PD here, for example, and you can combine Boolean operators such as OR and AND, and also brackets, and you can have exactly the equivalent query that you did as a fielded search. You can do it on the main text box using these query fields. So if you click search, hopefully, yeah, you get exactly the same results, so 12 hits. So if you want to learn more about these query fields and how to combine and create sophisticated queries, you can click this link, the query help, and then from here you can click this solution query field names and examples, and this is an exhaustive list of all the field names and examples of how you could use them in a query. You can also combine wildcards, quotes for exact searches, brackets for ranges of dates, etc. Right. Well, I guess one of the important things of the SureChEMBL interface is the ability to search, to do a chemistry search. So I would like to do a substructure search in this case. So I will use this SMILE string, which encodes a substructure. So I will use the manual structure input, open the box, paste my SMILE string, close the box, and that's the corresponding substructure. And then I can filter further the results. So let's say I want to search only against molecules that are extracted from either the claims, the description sections of the patent document, or they appeared in images in the document. And you can further filter. Let's say that I only want compounds from US, the US Patent Authority. So I would click search. So these are the hits of my substructure search, 3.6 thousand hits. The first thing I can do is I can download the hits. So there's a button called Export All Structures, and this will prepare a download with the hits of my substructure search. The other thing that you can do, there are two different views. There's this matrix view, but there's also the table view, so another way to see the hits. And then from here, I can choose two of these hits. Let's say the third and maybe the sixth hit, and I can do get documents for selected structures. This will go and will find the patents that these two documents, so these two compounds occurring. So there are only two US patent documents where these hits from my substructure search occurring. And again, you can export the chemistry from these documents, or you can view the full patent family or the family members for this particular document. So going back, you can also do more advanced substructure search by using, for example, more advanced queries. Let's say that you want to replace the oxygen in the furan with a heteroatom query. So click here, save and return, and again repeat the same search, and hopefully this search will find more hits containing both the oxygen and a nitrogen or even a sulfur. Yeah, so you have about 1,000 more hits. Finally, one more thing that you can do. So you can click this plus button. So you have more information about the compound, and then you can click on the View Chemical page. So this will take you to the compound report card for this particular compound with the name, some more information about the smiles and the entry string. And as I said, every compound in SureChEMBL has a unique SureChEMBL ID, which also forms the URL for this particular compound report card. And thanks to UniChem, you can also do a quick lookup across UniChem and see what are the other sources that include this compound. So in this case, there are only two sources, Thomson Pharma and PubChem. And if you click the third tab here, you can see in how many patent documents this compound has been seen. In this case, there are 4 patent documents associated with this compound. Right. So I think this is the end of the live demo. So I will go back to the slides. Right, as I mentioned, we have a dedicated page with a knowledge base, so a collection of articles related to the functionality and the capability of the interface. So feel free to use this resource if you want to. We also have a dedicated email address for any feedback or questions or problems. Please send us an email at SureChEMBL-help@ebi.ac.uk. And we also have our blog. I'm sure that many of you read the blog, so you read the announcement about this webinar. So if you want to stay up to date when it comes to more webinars or the new functionalities that we're going to add to the SureChEMBL resource, please follow this blog for new posts. To summarize, we gave you a brief overview of the capabilities of the SureChEMBL interface that we provide at the European Bioinformatics Institute, and that was followed by a brief demo of the interface. I would like to acknowledge my colleagues in the ChEMBL group and also the colleagues at Digital Science, without whom SureChEMBL wouldn't have been possible, and all of you for listening. I would like now to take some more questions if you have them. But before that, I would like to let you know about some future webinars that will be available via the EBI training here. All of the webinars will start at 4 o'clock GMT. And now, if you have more questions, we have about 5 to 10 minutes to answer these.
Hi there. Hi, can you hear me? It's Mark Davies. I was taking a webinar briefly. So just a quick question for Frank. Will future Open Facts data be hosted via EBI web pages? So essentially, we'll be generating some RDF for the Open Facts project, which will go into their system there. And as soon as that is made available, I guess once it's released into the project, this will be available ultimately on EBI web pages and as downloads. So yes. Scrolling up. So can we do UniChem lookups from multiple compounds at once rather than just one compound? So yeah, so programmatically, yes, you can do that. So quick question, many old patents are only available as TIFFs, not as PDFs. How do we handle these? So at the moment, we don't actually process the patent documents directly themselves. We use a third-party resource, IFI Claims, to this. So if they manage to extract that data using their own OCR techniques, then we can handle those. So I guess this is something for you to check with the IFI guys to see how those patents are being processed.
If you have an example, so if you have an example of such files of patent documents, yeah, feel free to check whether we have these in SureChEMBL. Another good question, would you consider building a maximum common substructure plugin directly into the SureChEMBL web interface? So yes, we have plans, well, for using maybe a maximum common substructure methodology or a similar methodology, trying to flag the compounds that are likely to be genuinely claimed as opposed to any other sort of noise, such as reagents, reactants, metals, fragments, radicals, etc. So I guess the first stage will try to, for every patent document, find and flag the compounds that share a maximum common substructure of sorts, and these will be prioritized because these will be likely to be genuinely claimed under the Marcus specification of the patent document. Wow, there are a lot of questions. Programmatic access to the keyword search be available in the future? At the moment, we're not planning to expose the API for the keyword-based search.
This may come through ultimately the OpenFacts API, which is made available, or ultimately, if we do develop our own and release an API, that would be available.
Yeah.
So, but in the short term, no, I guess.
And the keyword search would concern, I guess, the title or maybe the abstract of a patent. Will you also cover peptides with the Helm notation? So we do this, we encode our peptides and biotherapeutics in SureChEMBL using the Helm notation, but we haven't got any plans to do the same thing for SureChEMBL at the moment.
Yeah. I guess one of our shorts, we're not actually extracting the sequences from the patents at the moment, so that's one thing we would probably look to do, possibly a longer term goal to do that, and then if we've got the process in place for the SureChEMBL database, we could obviously look to do that for any protein sequences we extract from the patent literature.
Another question, tables with small images. As I mentioned, this is a problem, and Clyde sometimes fails because of the poor resolution. We were planning to try newer versions of Clyde, see if this increases the accuracy, but again, I guess there is no tool that could convert all the images in the patent documents with 100% accuracy, and that's because, for example, in some cases of the poor resolution or the small size of the images.